Hi everyone. For those who couldn't make it to the third session of Introduction to Python, I just want to share this recording to give a quick overview of uh, the presentation of the lecture. I will start my screen share. Yes, that's the right one. So during this session, we talk about data visualization in Python with two different widely used Python libraries called Matplotlib and Seaborn. First, a recap from what we did during the second week. We had to look at functions. One thing that we discussed was, well, why do we want to use functions in the first place? The main reasons are that it makes your code much shorter and much more readable, which also makes it much easier for other people to use. So I said, if you want to copy code, don't use a function. That is because a lot of the time, um, when you have a piece of code that works, you want to use it again, or you want to use it but for a slightly different purpose. And then you can copy that section of code and just adjust a few values and use it again. But then you get lots of code if you do that a few times. So instead, we use functions, and then you can, instead of copying the whole code, rewriting the code, you can call the function by its name and supply it with a number of arguments. And these arguments are values that are used in the function. So this can be any type of value. It can be an integer. It can also be a list or a dictionary. One other thing that was important was the distinction between local and global variables. So if you define a variable inside of a function, it's only available in that function. It's a local variable, and outside of the function, you cannot access it. Global variables are accessible everywhere in your code. So if you, in your main body of the code, on top start with the definition of a certain variable, it you can use that variable anywhere afterwards. And then functions, they consist of a few main elements. The first is the name of the function that we use to call the function. And then the arguments, we put that in brackets after the name of the function. Then we get, of course, the body, the operations that we perform in the function. And finally, we use a return statement, which ends the function and returns a certain value. You can define what you want to return, and that's a way to export local variables so that you can assign them to a global variable so that you can use them outside of the function. So today we will talk about first quickly about importing packages. I think that might be useful, and then we will talk about these two libraries, Matplotlib and Seaborn, for data visualization. So when it comes to importing packages, there are some functions that are built in already in Python. So for example, the lam function, we saw that earlier. If it gives you the length of a list, the number of elements in a list, and you can just use it. You don't have to import any packages. But for many more advanced or more specific things, you have to import a package first, and only then you can make use of the function. And when you do, you also have to tell the code where you get that function from, because it's not standard in Python. So you have to use the name of the library when you call the function. So how we do that, we saw the number pi earlier. If you want to make use of the number pi, you can use the numpy package, which has a function for pi. And if you do that, you can start your code with import numpy as np. And we use np to abbreviate numpy. And then later, when we use the function from that package, we write np.py. So from numpy, from np, the name we gave numpy, we make use of the function py. And the same we can do for Matplotlib and Seaborn. In this slide, you can see which names you have to use and also the common abbreviation. So importing it as PLT and as SNS is widely used, is very common. So I recommend doing this in your code as well. So the first of these packages, Matplotlib, is a comprehensive Python library for data visualization. You can do many types of data visualization. You can make static images like the ones that you see in articles. You can also make animated or interactive visualizations. So, for example, in a website, you can include a, a, a type of visualization where you can, with your mouse, the user slide a bar, for example, that changes the graph. All these types of things you can do with Matplotlib. And it's commonly used for scientific publications. And another advantage is that um, you can customize the layout to a great extent. So if you want to modify font sizes or change access labels, you can do these types of things, change colors. It has a lot of possibilities. So when we talk about data visualization in Python, I think it's important to go over a few basic concepts. First is the distinction between the figure object and an axis object. The figure is the window or the canvas on which everything is drawn. And the axes are individual plots in a graph, in a figure. So individual plots or graphs in a figure. So if you make one figure with multiple subplots, then you have one figure but multiple axes. And if you want to modify one of the subplots only, you have to remember that you need to modify uh, that axis object and not the entire figure. There are many plot types that we can make, like histograms, line plots, violin plots, anything you can think of pretty much. And like I said, titles, labels, colors, we can customize these things. The second library is Seaborn, which is also a data visualization library, and it's based on Matplotlib. So it makes use of functions from Matplotlib, but it provides a high-level interface. So this means that in few lines of code, you can do a lot, and you can also customize a lot. And it is very convenient. It's also used a lot in scientific publications. I think most articles that you find, certainly in the field of biology, that make use of Python, will have used Matplotlib or Seaborn or probably both. And to get examples of how you can make different plots, I recommend visiting the website because they provide examples of beautiful plots and you can just see how they do it basically. It's quite difficult to write the entire plotting functions by heart. Like most people, I think, don't know all the lines of code. So I recommend just having a look and copying and using it in your own way. Um, And then there are two exercise sheets for this section. The first is more basic and the second more advanced. They contain the same exercises, um, but yeah, good luck. They contain the same exercises, but um, the more basic version provides more of the code already. So that is a bit easier. I recommend starting with the more advanced version. And if you want more help, basically moving to the basic version. Um, Thanks for listening and good luck.